In this lesson, we're going to talk about how to choose the appropriate RAM module for a given PC system. Now, there are several different factors that you need to take into account. Otherwise, you're going to end up with a piece of memory that doesn't work in your particular PC. Let's take a look. The main question you need to answer when you're selecting a memory module for a particular motherboard is, what does that particular motherboard support? Different motherboards support different types of memory. If you buy the wrong type of memory, boy, you're in trouble, because a lot of stores actually won't take back memory. They say, boy, once you buy it, it's yours. So you need to make sure that you get the right type of memory before you walk out of the store. The first thing you ought to do is, of course, look at your motherboard documentation. It will probably tell you what type of memory can be used and how that memory must be installed. In addition, there are several different websites, such as Kingston Memory's website, that have tools where you can put in the type of motherboard you have and the type of memory you want to install, and it'll tell you, well, this module, and this module will work in your particular motherboard. However, if you don't have the documentation for the motherboard and it's not listed on a particular memory manufacturer's website, then you're going to have to use visual inspection to determine the correct type of memory. The first thing you need to look at is the memory type or form. We have two motherboards here. Notice that the memory slots, memory connectors on these two motherboards pretty much look the same. You know, they're a little bit different color. Other than that, they look the same. Well, they are radically different. This motherboard uses SD-RAM. This motherboard uses DDR-RAM, DDR2 RAM to be exact. The modules that go in this motherboard do not fit nor work in the connector on this particular motherboard. So, take a look at your motherboard, ask yourself, am I dealing with a DIMM, a SIM? Am I dealing with DDR-RAM, RDRAM, etc.? Another factor you need to keep in mind when selecting a memory module is the capacity of the module. Now, you may run down to the computer store and see, wow, a 1 gigabyte memory module. I'm going to put 4 of those in my system, and I'm going to have 4 gigs of RAM. Woo! I'm so excited. And you buy them, you bring them home, and all of a sudden you notice, wait a minute, I can only address 2 gigabytes of that memory. What's going on? The problem is twofold. First of all, most motherboards have a limit on how much memory they can address. The lower end, less expensive motherboards can address less memory, usually, as compared to a higher end motherboard. If you purchase a low end motherboard, you may find yourself limited to maybe 1 or 2 gigabytes total of RAM. Higher end motherboards may be limited at around 4 gigabytes. In addition to the total memory maximum, most motherboards also have specifications for the largest memory module they'll support. For example, you may have a motherboard that will support up to 2 gigabytes of RAM, but it only supports a maximum module size of 512 megabytes. That means in order to get your 2 gigabytes of RAM, you would have to purchase 4 512 megabyte memory modules. If you were to go out and purchase 2 1 gigabyte modules and put them in, the system won't recognize them. So you need to check and see what the maximum amount of memory that the motherboard is capable of addressing, and then you need to see how big of a module the motherboard is capable of addressing. Now, there's one little caveat I'll share with you right here. Many times when you check the documentation, it may say this motherboard will support a maximum module size of, say, 512 megabytes. The problem that I've experienced is that many times they say that just because that was the largest memory module that was available at the time that the documentation was printed, the motherboard was made. When in fact, if you put a 1 gigabyte module in there, it addresses it just fine. If you want to be safe, go with what the documentation says. If you want to experiment, you could give it a try and see what happens. It won't hurt anything. You'll just find that not all the memory is addressable if the module isn't compatible. Now, the next factor you need to keep in mind is that of speed. Now, back in the old days, when we dealt with SIMs that used FPM RAM, speed really wasn't that big a consideration other than for performance. We had modules rated at 60 nanoseconds, 70 nanoseconds, 80 nanoseconds. The lower the number, the faster the module was, and therefore the better performance. So if we wanted a really fast system, we would invest in a memory module that had a lower speed rating. 60 nanoseconds was usually the fastest you could get. With SIMs, the motherboard clock was in no way tied to the memory. With SD-RAM and with DDR-RAM, it is. When you go and purchase a SD-RAM module or a DDR-RAM module, you need to make sure that the clock speed of the memory module itself matches the clock speed of the front side bus of the motherboard. For example, if you wanted to go get an older SD-RAM chip and you're using a Pentium 2 system that has a 100 megahertz bus, then you need to purchase a memory module that's also rated with a 100 megahertz clock. Now, when SD-RAM first came out, they made them in 66 megahertz, 100 megahertz, and 133 megahertz. And so you had to buy the specific clock speed and match it up with your motherboard. Later on, they made memory modules that were multi-speed, meaning it was compatible with 66 or 100 or 133. Now with DDR-RAM, it's a little bit different story. With DDR-RAM, we're talking about higher speeds, and so you have to mate up the motherboard front side bus speed with the speed of the memory module. If you have a 266 megahertz front side bus, then you need to have a memory module that runs at 266 megahertz. Another feature you need to be aware of when selecting a memory module for a particular motherboard is the need for parity, or ECC. Understand that parity and ECC, they're the same, but they're not the same. The technical definitions for the two are slightly different, but we use them interchangeably because the actual concept is the same. When we're dealing with parity, what we're doing is we're adding one extra chip onto the memory module that is used to check for errors. You know, memory doesn't always work perfectly. There are times when corruption can occur due to a variety of different factors, maybe ESD. In the old days, there's actually problems with excessive radiation. If you had sunspots or something like that, the particles coming from the sun could actually go through one of these memory modules, and if it hit one of the capacitors just right, it could cause the charge to be lost, or it could cause the charge to be added and corrupt the data. We don't see that much nowadays, but in the old days, it was a bit of a problem. What we do is we add that extra chip, and what that chip does is compare the number of ones. Remember, data is stored in zeros and ones, charged or not charged. That parity chip stores the number of ones in a given byte when that byte is written to the RAM chip. Then, when that same byte is addressed and read again, it compares it a second time. In other words, when the byte is written, we say, okay, there was so many ones, and we store that over in this extra chip. Then, when that byte is read and the data is pulled out, we take a look again and say, okay, when we stored this, there were X number of ones in that byte. How many of them are there now? If they are the same, we know that the data is intact and has not been corrupted. If it's different, then we know something's happened, that the memory got corrupted somewhere along the way. Some motherboards will require that you use a memory module that is a parity memory module. Some won't. Check your motherboard documentation and see if it requires parity. If it does, then you need to make sure you purchase a parity memory module. Now, if you look at any given memory module, you can tell whether or not it is a parity memory module by the number of chips that are implemented on the module itself. Remember, we said when we implement parity, we add one more chip to the module. If there is an even number of DRAM chips on a given module, it is not a parity module. For instance, this one has 1, 2, 3, 4, 7, 8. If there's 8 chips on there, it is not a parity module. If it has an odd number, because we added that one extra chip over here to store the parity information, then it is a parity chip. Another rule that you'll sometimes hear when we're talking about memory is to take the number of chips on the memory module, and if you can divide it evenly by 3 or 5, it's a parity chip. If you cannot divide the number of chips on the module evenly by 3 or 5, then it's just a regular memory module. Now, in addition to parity, some motherboards will require you to use a memory module that uses what we call registered or buffered memory. Most of the motherboards that you buy aftermarket, for instance, if you're assembling a system yourself, usually they do not require registered memory, although there are exceptions. However, if you're working on a motherboard that's come from a major computer manufacturer such as Dell, IBM, or Gateway, more than likely they're going to require that you use registered memory. Basically what registered memory does is it has a buffer. It's usually implemented as a little horizontal chip right in the center of the module. Sometimes not, but generally speaking, that's what they look like. And this extra chip is used to hold data before it's transferred. If your motherboard requires registered memory, you need to fork out the money and buy registered memory. The one problem with registered memory is its price. If you were to compare with a memory module that's designed for a system that requires registered memory, they can be quite a bit more expensive. We're talking about sometimes double or triple the price. So when we build systems ourselves, we tend to go with the non-registered memory just because it costs quite a bit less. Now, in addition, this isn't a requirement with most motherboards, but it's something you want to keep in mind, and that is the type of metal that's used on the pins in the connector that plug into the motherboard socket. This is a great example right here. You can see that this module uses copper. This module uses tin. Now, some of these also use gold, depending on how much you pay for the module, copper or gold. But the less expensive modules use tin. Is there a difference in performance between tin and copper? Not really. They perform equally as well. Tin costs a lot less, and so for a time, tin was almost exclusively used in memory modules. However, tin has one major problem, and that is the fact that as electricity passes between the connector in the motherboard and the pin on the memory module, it tends to corrode just a little bit. Over time, that corrosion builds up on the tin connectors. As it does, the corrosion can get thick enough to the point where electricity can't pass through, and then we have a problem. This same problem actually happens on cars. Maybe you've had this happen to you before. What happens is that as electricity passes from the battery to the car through the battery posts and the connectors, oxidation builds up. As that oxidation builds, it creates resistance. And if that oxidation layer gets thick enough, the resistance gets high enough that electrical current can no longer pass from your battery to your car. You may have had this happen where the car's been running fine, starts up fine, and then you go out one day and try to start your car, and it won't start. It goes bleh, like it has a dead battery. And you're scratching your head going, well, you know what? It started just fine yesterday. I can't figure it out. A lot of times what happens is that those battery posts get corroded, current can't go through, acts like a dead battery. All you have to do is pop those battery cables off and then get a knife or a wire brush or something like that that's good and stiff and scrape out the insides of the battery connectors and on the outsides of the battery posts, put them back on, car works fine. The same thing happens with the tin leads on a memory module. Because of this, you probably won't see a lot of memory modules today that use tin leads. It was really bad. You'd have a system that was working fine one day, turn on the system one day, and all of a sudden, you don't have as much memory as you thought you were supposed to have. Did somebody steal my memory? You open it up, and you look, well, the memory's there, and you pull the leads out, and you could see a lot of corrosion on there. For that reason, you probably won't see many memory modules today that use tin leads. When you're dealing with DDR memory, such as this memory module right here, there's an additional factor you need to take into consideration, and that's its performance. And that is its CAS, C-A-S, latency, and its timing. The CAS rating is simply a number such as 2, 2.5, or 3. The timing is a set of 4 numbers such as 3, 3, 3, 8. We're not going to go into details to what those numbers mean. What you do need to understand is that the smaller the number, the better the performance. If you want really fast RAM, you can pick a module that has lower numbers and a higher performance rating. But before you do that, check your motherboard documentation and make sure that the motherboard will support it. Now, there's one more concept we need to talk about here, and that is the SPD chip. Now, SPD stands for Serial Presence Detect. The SPD chip is a small little chip that's implemented on SDRAM and on DDR RAM modules. Now, the SPD chip has a very special role. This chip, first of all, is the chip that sets the clock speed of the module itself. Remember, with SDRAM and DDR RAM, the memory has its own clock that must be mated up with the clock speed of the front side bus of the motherboard. In addition, the SPD chip also contains information about the specifications of that particular module. It communicates with the BIOS and tells the BIOS different memory specs for the particular module, such as its cache latency and its timing. I would strongly recommend that before you purchase any memory module, that you check the motherboard documentation first. It'll save you a lot of aggravation. In this lesson, we talked about the different factors you need to keep in mind when selecting any memory module for a particular PC system.